Okay, the figure is the graph of function of x. Okay, that's nothing new. Function of x models the height of a skateboard ramp. So you might come over here and say this is the height as a function of x. That just means that as you have a ramp, and as you move along the ramp in the x direction, the height is going up. Keep reading here. Function meets the following requirements. At x equals 0, right here, x equals 0, the value of the function is 0. So I'm going to write that down. So h of 0 is 0. Get rid of this stuff. And the slope of the graph of the function is 0. Oh, so h prime of 0. Again, key thing is to convert from words to math symbols. It makes the problem a lot easier to solve. I don't know why I'm boxing everything. Item 2, at x equals 4, the value of the function is 1. So I'd change color here. So h of 4 has to be 1. And the slope of the graph is 1. So h prime of 4 has to equal 1 as well. Part 3. Between x equals 0 and x equals 4, the function is increasing. So for the interval 0 to 4, h is increasing. Right there, I would remember that means from Danica's chart that h prime is positive. And just in case I need it, I suppose h double prime is therefore concave up on that interval. No, that's not right. Don't do that. Okay. Here we go, part A. F of x equals this thing. A is a non-zero constant, that's normal. Show that it is not, read slow and careful, not possible to find a value for A so that F meets requirement 2 above. So requirement 2, this is requirement 2 right here. Oh, I called it H, but they're saying it would be F in this case. So we're trying to say, can F of 4 equal 1? So here's my formula for F. Let's try it out. So that means 1 would have to equal A multiplied by an x value of 4, which means rearranging, we get A would have to equal 1 over 16. That's okay. If A equals 1 over 16, then F of 4 will equal 1. But we're also looking at F prime of 4 equaling 1. So we take our F, so F of x, A is a constant. So F prime multiplied by 2x. So now F prime, when x is 4, is supposed to equal A 2 times 4. But we figured out A is 1 over 16, so we can put that in. And this is all supposed to equal 1. So 1 over 16 times 2 times 4 is 8. That's supposed to equal 1, but it doesn't. 1/2 does not equal 1. So we have proven that it is not possible to meet requirement 2. So the f of x equal ax squared won't meet our requirement two. Here's how they gave points. 1 point for figuring out that a has to equal 1/16. And then the second point was for showing this right here. I don't really think you need to have that statement. They just said show. We showed it by doing the work in brown and the work in blue. So this work combined with this work, I guess the little extra in green, that would give us the 2 points. So part A, 2 points total. Okay, let g of x equal this. Show that g does not meet item 3. So item 3 says we're supposed to show that the function g is increasing from x equals 0 to x equals 4. So that's Danica's chart. So g is increasing as long as g prime is positive. So we go find g prime. I'm going to do this without a calculator. If they actually gave you a problem like this, you should find the derivative. They're not going to let you justify with g. You have to justify with g prime. And they're likely to have some symbols which would make it so you can't use your calculator. So we'll show how it's done without the calculator. So we've got 1 over 32, 3x squared, 1 over 16, 2x. So g prime of x is equal to 3 over 32 x squared minus 1 over 16, 2 over 16 times x, which means g prime of x is equal to 3 over 32 x squared minus 1 over 8 times x. So we factor to see what's going on a little bit more easily. So we can take out a 1/8 x. That's going to leave 3 over 4 times x minus 1. Okay, now what we have to show is these two things are being multiplied. When x is between 0 and 4, this will not make g prime negative, because we're trying to show that it does not meet the requirement. However, this right here is interesting. So we have 3/4 x minus 1. And so basically, let's see when this is equal to 0. So we get 3/4 x is equal to positive 1. Therefore, 3x is equal to 4. So when x is equal to 4/3, that's when g prime will equal 0. If x is bigger than 4/3, this would be positive. This would also be positive. If x is less than 4/3, this would be negative, and then this would still be positive. So we need to write that down in our conclusion here. So our conclusion is going to be, so show all that work, and then you write the conclusion, which is for 0 to 4/3, 4/3, g prime of x is negative, so g is decreasing on that interval. And therefore we have shown that g does not meet the requirement that between x equals 0 and x equals 4, g would have to be increasing. So we've shown that. They give us 2 more points for that. They gave 1 point for correctly finding g prime. So 1 point if you get this far. And then at that moment, if you feel stuck, just quit. Go to the next problem. But if you keep going and figure out and can get this explanation here, you'll get the 2nd point. So this part B was worth 2 points. Okay, a car travels on a straight track during the time interval 0 to 60. So just check that. Good. Car's velocity measured in feet per second. Velocity is feet per second. Acceleration, feet per second squared, are continuous functions. So that's A and B. So B is continuous, A is continuous. One thing to note, if A is continuous, that means V is differentiable. But we don't know necessarily if A is differentiable. Okay, table shows selected values. That's the same as always usually. I've never seen one that isn't, just selected values. Using appropriate units. We got to make sure we have the right units. Explain the meaning of this in terms of the car's motion. So Golden Notes has this one on it. You just write that down. So we say the integral from 30 to 60 of the absolute value of v calculates total distance, got to remember units, in feet traveled by the car for time interval, gotta remember units, 30 seconds to 60 seconds. And they'll give you 1 point if you have all of that. Oops, don't want that. Okay. Approximate the integral by using a trapezoidal approximation with 3 subintervals. So we're trying to do this integral. (30 to 60), absolute value of v, (30 to 60). Don't, again, slow and careful. 3 subintervals. There we go. Okay, so look at the first subinterval for trapezoidal sum. We have to take 1/2. We have to get the average of this. So we've got to go, the first subinterval, we have to take the value on the left and the right and take the absolute value of each. So we got to go -14 plus -10 and then the width of the subinterval is the 35 minus 30. If you want, you can write it like that. Full credit, you don't have to do any simplification. And just say plus, now we do it again. 1/2, parenthesis, left and right. If you want, you can do the absolute value in your head, is fine. So you can just have 10 plus 0. You don't have to write plus 0. This would be 50 minus 35. Safest thing to do is don't do the math, just write it down. Then plus 1/2, 0, and 10. So we'll just put a 10 that time. Showing some different ways you can do this. 50 minus 60, sorry, 60 minus 50. Like that. Read the question again. Approximate this using trapezoidal approximation. Okay, we are finding total distance traveled, so the units here are feet. They didn't say we had to have the units there because we have already had explained the units in the first kind of part of the problem right here, distance in feet. So we're okay with that. One more point for that. You don't have to do anything after that, just show those steps. So again, that was, well, that's part C. So part C is 2 points total. Okay, part D, using appropriate units, explain the meaning of this integral. So look at my golden notes, I find this box. I'm calculating the change in the velocity. So that's what I write. Write the integral from 0 to 30 of a of t dt calculates the change in velocity you need to remember units in velocity is measured in feet per second. Change in the velocity in feet per second for the time interval uh, 0 seconds to 30 seconds. 1 point for that. You have to have the units of seconds. You could say 0 to 30 seconds is fine. You have to have the units feet per second. And you have to have the right words. Change in velocity. Not rate of change, change in velocity, just like you see here. This is part D. This is going to be 2 points total. Then it says, find the exact value of this integral. Well, same formula. We need to do this. So, copy this over. So the integral from 0 to 30 of A will equal v of 30 subtract v of 0. Look up at my table. V of 30 is negative 14. V of 0 is negative 20. Stop there. Units here are always a good idea just in case. We're finding a change in velocity, so my units are feet per second. And just leave it like that. If you went one step further, this would have become negative 14 plus 20, which would have become 6 feet per second, but I do not recommend you keep going don't want to risk a mistake. One more point for that. That's why we wrote that part D was 2 points total. Part E, for the time period 0 to 60, interesting language, must there be a time when the velocity is negative 5? Justify your answer. Okay, that wording on the golden notes, you'll see those two boxes that are to remind you of the intermediate value theorem and the mean value theorem. Okay, they're giving us values of v, and they're asking about v. They're also giving us values of v prime, because a and v prime are the same thing. But the key is, if I'm given v, and I'm asked about v, that's usually intermediate value theorem. So I grab the box on the golden notes and I check to see if it works. Given values of v, the symbols on the golden notes are different than this. I retyped them, but same idea. Given values of v, explain why there must be one time between 0 and 60 where v, so given v, we're checking for v. So I look at the values of v and I see right here, there's got to be a value of v that's between negative 10 and 0 that would be negative 5, values of v. The intermediate value function is only valid if the function is continuous. So you have to write, since v is continuous, that makes the intermediate value theorem valid, and the value of the velocity at 35 is negative 10, the value of the velocity at 50 is 0. That's what we found up here. Those two values of the velocity surround the value we're looking for. Therefore, there has to be a time where the velocity is, that's where I would have lost my point, it has to be negative 5. And that would be worth 2 points. So this part E is 2 points total. Now you can get one of the 2 points if you show, like with my mistake, I would have gotten one of the 2 points because I did correctly show this information right here. That's worth 1 point. If you have all of the rest correct, you get the second point. The rest being you have to identify that v is continuous, and you have to have a concluding statement that by the intermediate value theorem, this is true. I would just copy the box. The wording in the box is perfect, so don't feel like you have to invent your own wording. Okay, so that was part E. Part F. From 0 to 60, must there be a time, so this sounds like the same thing again, intermediate value theorem or mean value theorem. Must there be a time when the acceleration is 0? Well, they are giving me values of acceleration. But there's no way to find a value of the acceleration on any interval that would be 0, because there's no intervals where the acceleration value appears to have to go through 0, because all these accelerations are positive. So that's making it look like I can't use this. So now I'm going to look for the mean value theorem. Well, they are giving me values of v, and they're asking about v prime. That's mean value theorem. But to use the mean value theorem, I have to show that v is differentiable and continuous. They tell us that v is continuous, but they also tell us that a is continuous. And we said earlier that means that v is therefore differentiable. So I wrote that here. Since a, which is v prime, is continuous, therefore v is differentiable. So now I know I can use the mean value theorem. So mean value theorem means go find a secant slope of 0. I'm trying to prove that there's a tangent slope that is 0. I find it right here between time equals 0 and time equal 25. So I use those values in that box with the mean value theorem right here. Okay, this one box right here is going to get you 1 point. And then to get the other point, you do have to have all of the remaining information. You have to have this statement. So 1 point comes pretty fast. Second point is more work. You have to have that. And then you have to have this. So the blue is what's going to get you the second point, or 2 points total. So part F, 2 points total.